Okay, you guys, we're going to continue our discussion on working with complex numbers. In this video, we're going to work on dividing imaginary numbers. Okay, so just like before in the previous video when we were multiplying, we don't just want to divide radical expressions that have negative signs in them. We're going to want to separate their negative parts out from their positive parts, just like when we did when we multiplied. So in these directions, it tells us to divide. So let's work on A. A says the square root of -4 over the square root of -16. So what I'm going to do is break those up into their negative and positive parts. Okay, we know that the square root of -1 equals I, so anywhere I see that, I'm going to make that replacement. All right, so it's going to be I. The square root of 4 is 2. In the denominator, I'm going to have I. The square root of 16 is 4. Okay. Now we have an I in both the numerator and the denominator, so they can cancel. And that's going to give me 2 over 4. And we're going to reduce. 2 over 4 reduces to 1/2. Okay. All right, let's do B. So B has the square root of -45 over the square root of 80. So once again, we're going to break those up into their negative and their positive parts. Okay, the square root of -1 becomes I in both the numerator and the denominator. Now let's work to simplify the square root of 45 and the square root of 80. So those are both not perfect squares, so we need to break them down into primes. All right, so 45 can be broken down into 5 times 9, and 9 is 3 times 3. So your numbers can come out in pairs. So we have a pair of 3's, and the 5 will be left behind. So we have 3 square root of 5 for the first one. All right, let's break down 80. That's 2 times 40. 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. So remember, our numbers can come out in pairs. So I have 2 pairs of 2's, and the 5 will stay behind. So 2 times 2 is 4, square root of 5. All right, so let me put those back into our problem. All right, so the numerator is going to be 3 square root of 5, and the denominator is 4 square root of 5. Okay, so the I appears in both the numerator and the denominator, so we can cancel it. Okay, and so does the square root of 5, so we can cancel that as well. So that's going to leave us with 3 over 4. Okay. All right, let's do C. So once again, I'm going to break these into their negative and positive parts. Okay, the square roots of -1 become I. The square root of 3 doesn't break down any farther, so I'm going to leave it. So same thing with the square root of 7, doesn't break down, so I'm going to leave it. Okay, we have i's in both the numerator and the denominator, so they're going to cancel. So that's going to leave me with square root of 3 over the square root of 7. Okay, now the way that problem is, we can't leave it the way that it is. Okay, we're going to have to rationalize it because a radical is in the denominator. Okay, so don't forget. Actually, let me write that over here. Okay, so when we rationalize, we're going to multiply the numerator and the denominator by the expression that's in the denominator. So I'm going to multiply both by square root of 7 over square root of 7. All right, so we're going to multiply them together. So the square root of 3 times the square root of 7, that's the square root of 21. And the square root of 7 times the square root of 7 is just 7. Okay, so it would equal the square root of 49, and we know the square root of 49 is 7. All right, the square root of 21 doesn't break down any farther, so this is going to be our final answer. Okay, so don't forget, if you have the radical in the bottom of your problem, in your denominator, you have to rationalize. Okay, so don't forget that step. Cool.